All right, we're good to go. Yeah, that would be a good improvement for Zoom if it could like remember where you have your windows. Um, there's so many things on computers that I wish I could just like automate, and you can do a lot of that through Unix, but some of the stuff still doesn't work very well. Um, but in Unix, if you're running, a native Linux operating system, there are window manager commands you can put in a shell script that will do things like, move your windows around, set the size of them. If you have multiple desktops, control which desktop they're on and so forth. We may get into some of that in here, but I use a lot of that. For example, to set up my cameras, this is just a program called GUVC View, and I have 2 instances of it running. And I can just say cam setup, and it automatically opens up this one on my document camera, and it sets the size, and it moves it to this window and slides it up so you don't see the title bar, and then opens up this window, and it makes that camera window sticky so that as I change desktops it's always visible, and so on and so forth. So you can actually do some of that automation and repeatable control through Unix by writing scripts and such. So it's part of why it's fun to work in Unix. All right, any questions? Had a few people
Sure.
come into office hours for... Yeah.
I was working through that last night, and I was curious as to, I'm assuming that when I go to set up my VirtualBox Linux program, that I'll want to run pretty much all that same stuff to set up Git to push from there to the repository as well.
Correct.
However, I guess if that one, would they be pushing to a separate repository, or do I have to, or would I not be running, say, the initial Git, because that project's already there, I just have to connect to it.
So we're going to talk about this today. This is going to be the whole lecture today, is all of these things Git. But the short answer is you're basically going to have one repository in the cloud, something like GitLab. But then each machine that you're working on, you're going to have a local repository. And then the whole deal is you basically take your local repository and you keep it in sync with the repository in the cloud.
Is that where the cloning comes in?
That's where cloning and push and pull come in, yes. So we're going to work through this in detail today. And by the end of today's lecture, everybody should be able to do homework too, without too much complication.
Alright, so just to clarify, we're going to have basically one giant repository for this class.
Exactly, yeah.
Okay.
All right, so let's talk a little about Git. I mentioned it the other day, but let's go into more detail. So imagine that you're working on a programming assignment, and you're going to be working on this assignment for a week. And this means you're going to periodically come to your terminal window, and you're going to go into the editor and write code in a file, and then compile it and fix your syntax errors, go back in, change it again, and so on. And at some point, run your program, and maybe it works, maybe it doesn't, so you're going to write some test code and figure out where the problem is, fix it, and maybe eventually, get this thing done, but then decide later that you want to make some changes to it. So you're going to come back and you're going to add some features to the code and so on. And mostly we do this just by, using VI to edit the file, GCC to compile, and so on. Maybe we write, a file in there called README that says, hey, don't forget to go back and add this feature sometime. But if we're working on this by ourselves, it's usually not a real problem to sort of organize our work, because we're the only people going in making these changes. We're the only people who are adding or removing features and so on. But if you're working on a group project, let's say you've got 3 teammates that you're working with, so all 4 of you are developing a computer game. And one person is working on, the player movement, another person is working on the power-ups, and 2 other people are working on the bosses, right? And trying to write the code for the boss battles. And to some degree, you're working on different pieces of the project, but there's also a lot of overlap, right? If you're writing the code that deals with the final boss battle, you're also dealing with the code for the player moving around and the power-ups that the player is going to use and so on and so forth. So there's a lot of overlap. And it becomes a challenge, for example, if the person who's writing the code to handle the player movement goes in and starts making some changes and decides, I'm going to add an option so that you can move quickly, right, by using a power-up, right? And the person who's writing the power-up code is making some changes to how you access power-ups and so on. And so you can start interfering with each other's code and each other's development. And this becomes really, really problematic very quickly. It can also be a problem because, for example, maybe the person who's writing one piece of code decides, I didn't really take the right approach for this. I should be doing this totally differently. And they delete the whole set of code they wrote and they start over from scratch. Well, what happens to the people working on another part of the system that are still using your old version of the code, right? You're going to take your final version and say, here's my version of this code, and it doesn't work with what the other people have developed. And so there's all kinds of issues around shared code bases when you're doing development. And so when Linux was being developed, right, you're talking about, thousands of people working on, millions of lines of code and trying to coordinate that. Trying to make sure that, if I'm testing some feature on some set of code, it doesn't break what these 20 people are doing because they happen to be using the same piece of code. So there have for a long time been different source code control systems. Ways to have a common set of code stored somewhere that other people can pull from, make changes to, and then put back. And so CVS was the first code system I used, really, really old system. But there's been a whole slew of these source code control systems. And when Linux was being developed, they were using a source code control system that was pretty popular at the time, and it was free, right? And Linux was a labor of love. It's an open source project, and so the people who were working on this were doing this mostly because they liked coding and they liked hacking and they wanted to be part of a cool large project. So they were using this free source code control system. And partway through the development of Linux, the people who controlled that source code control system decided, hey, we can make some money here because all these people are using this. So they started charging for it. And they said, okay, you're going to have to pay us, I think it was a monthly fee to use this software. And that didn't go over very well, right? Especially with an open source crowd. So the people working on Linux developed their own source code control system. And it's called Git. And this is probably the most popular system of its type in use today, right? Git is pretty ubiquitous. If you go to GitLab or GitHub, there's a ridiculous number of projects out there. If you are working on an Arduino processor, a little self-contained microprocessor, and you want to pull down code so that you can hook this up to multicolored LEDs, right? You'll probably pull the code from a GitLab or a GitHub repository, right? This is the way that people manage source code today. We're going to use it throughout the CS sequence here at Clark. If you go to WSU, you're going to use this in the majority of your classes. In some classes, you'll probably be assessed, you'll be graded on your repositories, on how you use them, on what kind of commit messages you put in them, on how well you're sharing the code among different people in a team, and so on and so forth. And a lot of jobs that you look at, if you look at required qualifications, they'll mention experience with source code control, such as Git. So it's a really powerful tool. It's a really useful tool, and it's going to help you out down the road to become very familiar with it. So there's a few different versions of Git experience. So the first thing I want to start with is the idea of a local repository. So a repository is a place where you store code, basically. It's a fancy word. And here's the basic setup. I'm going to be sitting on my laptop. And I'm going to have a directory. And this directory is going to have a series of files in it. I could have subdirectories in there also, right? But some sort of file structure sitting in this directory. And what I'm going to do is I'm going to create a Git repository. And periodically what I want is to take my files from my directory and copy them into my Git repository. And my Git repository is not just a copy of my current files, but it's a history of my files, right? It's something which will show me across time every change that I've made in here that I've recorded in the repository. And because it knows the history of my work with these files, I can go back and I can look at older versions of my files. In fact, I can go back and I can look at my entire directory as it was, 14 days ago, if I've been using Git in a regular way. I can go back and I can look at an old version of my directory, and then I can come back to modern time and say, okay, show me what my directory looks like now, and so on. So the first thing we're interested in is how do we set up a Git repository, and how do we cut our files from our directory into that repository. All right, so send me an attendance note. I think everybody's here who's going to be here, so send me a note with your name and a here to let me know you're here. And let's go ahead and play around with this a little. So I'm going to make a CSE224 directory. All right, so let's suppose that this is the directory under which I plan to do all my work for the course, so CSE224, and there's nothing in here right now. All right, so I'm gonna make some files. So I'll make a file called project1.c. This is my project. All right, so here's one project that's going to be in my directory, project1.c. It's standard practice when you're working in a directory on a project to create a file called readme or readme.md, and it's basically just something that it's just a text file, but it's a sort of recognized place that you can go to find out information about what sorts of files are stored in a directory. So we're always going to want to make a readme, and if you do a .md, it means you can add some formatting to the file as well. We're not going to worry about that for now, but just make a readme.md. All right, so there's my readme file, complete with typos. All right, I've got two projects in my directory right now. And what I want to do is I want to take those projects and put them into my Git repository. All right, so one time at the beginning of this project, I need to do a command, which is git init. Okay, this only has to happen once per project. So I'm just going to say git init. And it tells me initialized empty Git repository. So that git init creates this repository. It's got nothing in it yet, but it's sitting there. What I want to do next is I want to take my files from my current directory and copy them into my repository. And we do this in 2 steps. So there's a staging area. And the first thing we do is we take the files that we want to put in our repo and we push them into our staging area. So the command here is git add. And git add will take our files, copy them to the staging area. And then if we want to copy them from the staging area into the repository, we say git commit. So 2 steps. Git add puts it in the staging area, git commit puts it in the repository. So I'm going to say git add readme.md and git add project1.c. And I can always say git status to see what's going on. So if I say git status, it'll tell me, hey, I've got 2 changes waiting to be committed. I have a new file called readme, a new file called project1. And they need to be committed still. Alright, so I've done my git add, and I'm going to do git commit. And when you commit your files, you have to put in a message in here saying, why am I committing these files? Right? This is this idea of working with a team of other people. But this is also useful for ourselves. Why am I putting these things into my repository? Well, I just started, right? So I'm just going to say, you know, initial commit. This is just like the first time I'm doing this. All right? And we're done. If I say git status, it'll tell me that my working tree is clean. It means there's nothing that needs to be added or committed right now. So I did a git add to put my files in the staging area. I did git commit to push from the staging area into the repository. I'm all set. Okay, now let's say I make a change. So project1.c doesn't actually do much yet. So let me add a print statement in there. Okay, now if I do a git status, it'll tell me, hey, I've modified project1.c. It's in red, right? It's not on the staging area yet. It's not committed. So it's telling me I've modified this. Hey, I probably want to go ahead and push that into my repository too. So git add project1.c and then git commit. Okay, why am I committing this change? So I just added a print message to project1. Alright, so what did I do? I just took that file, I modified it, I pushed it onto the staging area, I pushed it into the repository. And you're going to do this every time that you work on your code and you feel like you're at a point where you want to save it, which should be more often rather than less often. Go ahead and do your git add, do your git commit. And like everything, there's a lot of ways to do this. If you're lazy like me, I can just do git add star. And that'll take everything in my directory and push it on the staging area. And that's not going to be too bad a thing to do for at least the beginning of this course. Usually I don't want to take things like, you know, compiled code and push that into the repository because it takes a lot of space and I don't really need to be able to get back to my compiled code. What I'm really concerned about is my source code. If I have all of my .c files, my .h files, my make files, and so on, I can rebuild the executable. And in fact, if I want to run my code on a Raspberry Pi, I can't just take the executable from my laptop and put it on my Raspberry Pi. I have to recompile it because the CPU is different on my Raspberry Pi. It understands different machine code. So mostly I'm going to take, you know, source code files, readmes, text files, make files, and so on, put those in the repo. But it's not too bad a thing at this stage if we just say, you know, add everything, just git add star. And so if I update my README, okay, project 1 is looking better now, and I can try this. And that seems to work. That's fine. Maybe I want to put a new line. Don't want to execute. Don't want to edit the executable. Maybe I want to put a new line after this. So I'll recompile it and I'll rerun it. Okay, that looks good, right? I've got a bunch of stuff. It's not too bad. I'm just going to say git add star. Git commit. And I'll say this is a working version. Alright, and I'm done. Git add, git commit. Git add, git commit. Just keep doing those two. Alright, so what's happened here, right? I've made multiple changes to my files here. I've created new files. I'm keeping my repository as a running history of what's been happening to my files. And at any point, I can say git log, and it will show me that history, a condensed version of it. My initial commit was at 11:18. At 11:20, I added a print message to project 1. At 11:22, I had a working version. And if I want, I can go back to old versions, and so on and so forth. Okay, this is, a tiny little bit of Git. Git is this huge thing that, there's entire courses on it. There's multiple books that you can buy on Git. But we're cutting a really thin path through a handful of commands used in a very few particular ways to do what we need to do. All right, so this is a local repository. This repository is stored on my laptop, just like my directory. In fact, the repository is stored inside my directory. And if I look in my directory, I've got my project, my compiled version, and my README. But if I do an ls-a, I've also got a directory called .git. And .git has a bunch of stuff under it. Right? All these files. Now what are these things? I didn't create these things. Git created these things. And these are the files and directory structure that contain all of the information you need to be able to get to and work with the history of my files. So we don't want to mess with those. Right? Unless you really know what you're doing, you don't really want to even go into that .git directory. If you mess around with that, you can totally foul up the Git structure and make it so that you can't work with Git anymore. You can't get back to the old files and so on and so forth. If you want to mess with it, make a repository that you don't really care about and go ahead and take a look in here and play around with it and so on and so forth. But don't monkey with .git in a directory that you actually care about, the files and so on.
So can you create more directories within your current directory that has your Git directory?
Mm-hmm.
Push
Yeah.
the whole directory.
Right, so I'm in a subdirectory called homework002, and I've created a file called go. I can go ahead and add that. And we're good to go. I could also, from my original directory, CSE224, this is where I first started from, right? If I do a git status, it'll still tell me I have a directory, homework002, with a file go to, and that has not been committed. And if I do my git add star, it'll go ahead and add that. So if I do my git commit, it'll tell me, hey, it's about to commit a new file, homework002, go to. So it's
So
pretty
to add that whole
painless.
thing as a new directory, but still be in the same Git file or Git repo.
Yes, yes, and that's exactly what we want. We want one Git repository. And for this course, you're going to have one repository for the whole course. It's going to be called CSE224. And everything that you do in this course, every programming assignment, every homework, is going to be a subdirectory underneath the CSE224.
How important
How you
is it that that CSE directory is capitalized?
I would make it capitalized, but Git doesn't seem to care about repository name case. So I would suggest making it capitalized, but if you don't, just try to be consistent. If you make it lowercase, stick to lowercase. So on Unix, everything is case sensitive. And if I make a directory uppercase CSE224, and I try to CD to lowercase 224, it'll say no such directory. But if I call my repo uppercase and I try to fetch it with a lowercase, that seems to work. But I would say stick to uppercase. All right, so this is part of the story, okay, and this gets us, you know, a nice history of our changes and such. But that repository is sitting inside this directory. So if everything works the way it's supposed to, this is great. But suppose I accidentally delete this directory from my system, or suppose my hard drive fails, or suppose my laptop gets lost, right? This .git directory, if that goes away, I don't have a repository of my files anymore. So the next thing we want to do with Git is we want to take our repository and we want to clone it into the cloud. And this gives us offsite storage. It gives us an offsite place that we can use to make copies of our repository onto other machines. And it gives me a way to look at your code so that I can grade your assignments. So we're going to copy our repository to the cloud, and we're going to use a place called GitLab. So you want to log on to GitLab and get yourself an account there. And let me just go ahead and do this. So GitLab.com, I'm already logged in because it's a pain for me to log in. But when you first come to GitLab, if you haven't logged in, it'll bring you to a page that lets you log in or create an account. Okay, so if you don't have a GitLab account, make yourself an account, use a real username, use a username that you can remember, use a real email address, it'll send you a verification email and so on. And then you're good to go, you can log in. So when I log in, I can see my projects. I've got 72 projects here, and they go back, you know, a number of years to some of the older stuff. And each of these is a Git repository corresponding to, you know, some directory structure that I had on a machine, usually a Unix machine, that I was doing work in, and I was synchronizing my changes to GitLab. Alright, so what we're going to do is once we have some stuff in our repository, we're going to want to push it into our GitLab account. And the main way we're going to do that is we're just going to say git push. And that's going to make a copy of our repo onto GitLab, and it's going to record the history, and it's going to note changes and so on and so forth. Okay, so this brings us up to homework 2. So let me pull that up. All right, so before you can do any of this, you need to do some one-time setup. Okay, a lot of this is one-time setup. First thing you want to do with Git is these 3 commands. Git config -- global core.editor vi. This will tell it when you're doing a commit message to use the vi editor. Otherwise it defaults to nano, which is not a bad editor, but if you want VI, set this up. And then make this whatever username you're going to use for GitLab, and make this whatever email address you used for GitLab. Okay, these only have to be done once, and they get saved in a file in your home directory. So until you move to another laptop, right, you're good to go after you've set these up. All right, and here's a reminder of what we just worked through: git init, git add, and git commit. Okay, git init is once per project, and for this quarter it's once per quarter, and so it's just git add, git commit, and some other useful commands: git status, git log, and so on and so forth. Okay, so when you want to work in the cloud, you have another one-time setup you have to do. This only has to happen once. This is called generating a public-private key pair. And the command is just this: ssh keygen trsa b4096c, and then your email address that you used for GitLab. And when you do this, it will ask you 3 questions, right? The first one is, what directory do you want to put this in? Just hit the enter key, take the default. And then it'll ask you for a passphrase, hit enter. It'll ask you for the same passphrase again, hit enter. Okay, so it's going to ask you 3 questions, hit enter each time. And when you're done, what this will do is create a pair of files in this directory, /.ssh. So if you're doing this from the laptop, if you go into this .ssh file, you'll see these 2 files, idrsa and idrsa.pub. Alright, these are a pair of files, each containing what's called a key. So we can look at my public key, and it's this big long string of characters and digits and symbols. And this means nothing to us, but it means something to a computer. This big long string of symbols corresponds in some very complex way to the string of symbols contained in this file. This is my private key. I'm not going to show you this one. Nobody gets to see the contents of this file except me. It doesn't get transmitted anywhere. It doesn't get shared with any other machine or person, right? It's private on this machine, and it does not leave this machine. But here's what happens, right? If somebody knows this public key, they can ask me a question, and the only way I can answer it is if I know my private key. And if I answer it correctly, they can tell, and if I answer it incorrectly, they can tell, without having to know what my private key is. Okay, so this is an asymmetric cipher. We'll talk about this in CSE215. But basically, it's a way to be able to authenticate that I am who I say I am without having to send anything that could be compromised by somebody looking at it. So we share the public key, but not the private one. But somebody can confirm that I have the private key that corresponds to this public key. So if I tell GitLab, hey, let in anybody who knows the private key corresponding to this, I'm the only person who can get into my repository. So we have to set up this handshake, right? So you do this SSH keygen command. It creates this pair of files. What you want to do is take the contents of this file and give that to GitLab. Okay, so how do you do that? Hop onto GitLab in your account and click on Preferences and come down here to SSH keys. And in here you just want to paste that public key. And you can give it a name that you want and then say add key, and that's all you need to be able to log into GitLab and push your repositories over. And you can have multiple keys, so any machine that you're working with that you want to be able to get to your repositories, you want to do the same thing, create a key pair, and then take the public key, right, idrsa.pub, and add that key to GitLab's list of keys. All right, so once you do that, you're done setting up your authentication with GitLab. And this is just a way to avoid having to type a username and password every time that you want to push things over. All right, so you have one more one-time setup to do. This is one time per repository, which for us is once for the entire quarter. Since we're going to try to push our repo into GitLab, we've got to say, where should we push it? Because GitLab can hold, a lot of different repositories. So which repository do we want to push this into? So we have to tell the system that information. That's done with this git remote add origin command. So you're going to say git remote add origin git at gitlab.com : your name on GitLab / and then the repository name, which for us is going to be CSE224 and then .git at the end. So let me do this. All right, so here's my CSE224. Let me make sure I don't have a CSE224 project yet. I don't. Good. Okay. So I'm going to do git remote add origin git at gitlab.com : Nick Macias / CSE224.git. All right, that's my one-time setup. I don't have to do that again. If something goes wrong and you need to execute this command again because you made a typo or something like that, you can't do it more than once. It'll tell you it already exists. So you have to undo it, and you do that by saying git remote remove origin, and then you can do git remote add origin. If you don't make typos, don't worry about it. All right, so at this point we've only got one more command we have to do, which is push. Git push origin master. So I'm going to say git push origin master. And that's it, I'm done. So if I go back to GitLab and I look at my project, right, my last project was from 2 weeks ago. If I refresh that, there's a CSE224 project now. And if I click on it, there's my files. There's the README, there's project 1, there's project1.c, and there's a directory homework 002, and it has a go and it has a go to. And I can come in here and I can look at the history of my files, and I can see all the different commits that I made and the commit message that I put in, and so on and so forth. And from this point, it's really, really easy, right? Git add, git commit, git push. So let's say it's time for programming assignment 1, right? So I don't know what I'm going to have you call it, but let's say I'm making you call it PA1. And we'll have a main.c, and we'll have a make file, and so on and so forth, right? I want to push those over to GitLab. Git add star, git commit, git push origin master. And now if I come over here and I look at my project, CSE224, there's a new directory, PA1, and it's got my files in there. And I can open that up and I can look at my files and so on.
And it looks like you can actually edit the files from there.
I don't think you can edit them from here. Now I could upload new files here and so on, but I would avoid that, right? There's all kinds of things we can do with Git, but life is easiest if we simply go in one direction. Work in our directory, add, commit, push. But we can go in other directions, and sometimes we do want to do that. So let me.
If you're on your computer and you edit it, and you do this process again, will it just overwrite the file that's in there then?
It'll overwrite it, but it'll remember the old version also.
Oh, okay.
So what should we do? Let's vi our make file. All right, so let's come back here. Let's go back to our 224 PA1. Let's look at our make file. All right, so there's the new make file. Let's take a look at the history. So here was the old version of it. I can click on that, and there's the old version of it. And I can go back and view it as it's an uninteresting file because it was just one line of gibberish. But I can get back to the old copy like that.
And so in the history, it looks like it actually shows you the reason too. So if you're writing a program and you say, you know, why am I overwriting this? Because I fixed the error with this. It actually show up there. Okay.
Yep, exactly. And this is why it's helpful to make good commit messages, right? Because you'll use those sometimes to say, you know, at 3 in the morning, I jumped out of bed and I thought I was going to make this brilliant change to my code, but I totally messed it up, right? So I want to get back to a version that worked well. Well, if you got a good commit history, you can go back and say, oh yeah, I want to go back to the version when I added the such and such feature. So that can be useful. All right, and then let's say that that you're on the Linux server. And I want to make a copy of my repository. It's one command. Git clone git at gitlab.com /Nick Macias CSE224.git. And now I've suddenly got a new directory called CSE224. And if I look in there, there's my repository. And there's the stuff that's in PA1 and so on and so forth. And if I say git log, right, I can see my whole history of changes I made and so on and so forth. And then if I were to make changes on the Linux machine, I can come back and I can get those on my laptop. And that gets a little trickier, and that's where we can start to get into some trouble. But we can play around with that later. We got 6 minutes. Let's see. Let's clean up our. Let's clean up main.c. All right. So there's something that'll at least compile. So I'm just going to say git add main.c. Git commit. We can compile it now. Git push origin master. All right, so that pushed over to GitLab, right? I just did something in the reverse direction. I had another repository over here, and I pushed up into GitLab. So if I come back to my laptop, what I want to do is pull from GitLab into my repository. And so I can do the following. Right, and I've still got my goofy version of main.c. If I just say git pull origin master, that gets my new version of my file. All right, so let's.
So when it pulls, does it put it in like your Git repository, or it fully takes it all the way back to your directory?
It pulls it from the from the cloud, from GitLab into your repository, And it basically gives you a copy of what the repository looks like in GitLab in this case. But it doesn't just copy everything over, right? It looks at changes and so on and so forth. And it makes sure that when you copy from GitLab into your repository, you're not going to clobber work that you've already done. And this is where we can start to get in trouble. If I make some changes on one machine and I make some changes on a second machine, and then I push from the first machine up and then I try to pull those down, those changes might contradict something that I've already done on my laptop in this case, and Git will complain about that. And that's a whole topic in itself, how to deal with that, how to avoid that, and how to resolve it. But for starters, right, if we just stay with one direction, if you just work from one source, and any time that you make changes, do an add, commit, and push, we'll be pretty safe. All right, so let me run quickly through the homework. We've pretty much done all of this at this point. So I've got this set up for working from the Linux server, because you always want to make sure your code works on the Linux server. So on the Linux server, make a directory called CSE224. This is going to be the root for all the work you do in this course. And from that directory, do your git init, make a readme file. You can say touch readme, it just makes an empty file with that name. Add commit, you can do a commit-m with a message, or you can just say git commit, and it will bring up that VI window that you can type into. And then do that git remote add origin, and then git push. Okay, at that point, if you log into GitLab, you should see your repository. And so if I go to my projects, right, I'll see my CSE224. Okay, so one time only, you need to set me up so that I have read access to your repository. So go into your project, project information, members, and then GitLab member or email address, type in Nick Macias, that's my GitLab ID. Click on that. Select a role, make me a reporter. That gives me read access, but I can't modify, and then just say invite. And that's all you have to do to set that up. All right, so that's what this tells you how to do. And then go back to your 224 directory, make a subdirectory, homework 002, make a readme.md file. Give me one or two sentences about, you know, why you're here, what your background is with Git, whatever you want to tell me, right? Just put a couple of sentences in there. Git add, git commit, git push. Okay, you don't have to do add origin, you don't have to add me as a reporter, SSH keys, that's all set up once you're done for the course. So just make a new file, git add, git commit, git push. And then the last thing you have to do is tell me your Git user ID. Okay, and I want you to do that on the Linux server. And so log into the Linux machine, and don't do this in general for sending me email, but this is useful for me. It's convenient for me for getting your Git IDs. So how do you send me email on here? Mail Nick. And then subject should be git : followed by your username. And I want you to do your subject exactly like this, because I'm going to scrape these with some tools. So git : and my Git ID is Nick Macias, so I would just do that. And then hit enter and just type a single period followed by an enter. That will end your mail message. You just hit a period and an enter. It'll say null message body, and you're done. And you can log out, and you're done with homework 2. All right, so try to do that today. If you run into problems, come to office hours tomorrow morning. We can work through it. All right, so please send me one final attendance ping, and I got a few questions in email. I'll see if I can answer those quickly. But send me an attendance note, let me know you're here, and then you're good to go. I will see you next time. Let's see, I know this is unrelated. Tried assessing homework due at 8, and return Java connection refused. So if you try to assess and it says connection refused, it means the server is not running. So if it was due at 8 and you tried to assess after 8, you would have gotten that error message. Should we be doing the ODPs in the 224 folder? I think that's a good idea. I would make a subdirectory called ODPs and then make a separate directory under that for each of your ODPs. The advantage there is if you're working on an ODP and you're having trouble getting it to work and you come to office hours, right? If you've pushed that over to Git, I can easily pull down your ODP and see what you're doing, right? And maybe give you some help with that from there. So you don't have to do that, but that's not a bad approach.
Hey, just to clarify, you said when we're doing the attendance pings, for some reason when I keep doing my dash and then here, I keep leaving the space out between those two. You said that doesn't matter as far as your scraper goes, right?
Yeah, space doesn't matter. I don't actually have a fancy scraper. I have something that pulls out those messages, but then I go through them by hand and put them into the attendance list, and if somebody's not there, I'll usually go through and see if they, you know, misspelled here or something like that. So it's not as automated as I'd like it to be, but the closer to that format, the better, yeah. So don't worry about spaces. All right, have a good one. I will see you next time.